Did you know that motion is one of the most fundamental aspects of the universe? From the planets orbiting the sun to the tiniest particles vibrating in your hand, motion is everywhere. In today's video, we are going to talk about how things move, and we won't just talk about the basics. We'll start by looking at motion in one dimension. Motion is a core concept, and it can be described in various ways depending on the context. Everything in the universe is in constant motion, including Earth, even when you're at rest. Motion signifies a change in an object's position over time. Let us now understand the terms motion and rest. Motion. Motion refers to the state of an object when it's changing its position concerning a reference point or frame of reference. Objects in motion have some fascinating characteristics: speed, direction, and acceleration. These elements combine to give us a comprehensive understanding of how objects move. Rest. Rest describes the state of an object when it's not changing its position concerning a reference point or frame of reference. In simpler terms, when an object is at rest, it's like a statue, it's not going anywhere. In other words, its speed is zero, and it remains stationary relative to its surroundings. Here's an interesting tidbit. Motion and rest are relative terms. That means whether an object is in motion or at rest depends on your point of view. Think of it like this: imagine you're on a train, and the person sitting across from you seems to be at rest. But if you look out the window, you'll realize they're moving with the train. In this case, the train is your frame of reference, and it's all about how you're observing the object. In fact, there's no absolute state of rest or absolute state of motion. It's all about perspective. You're both at rest and in motion simultaneously depending on where you're looking from. Let us quickly solve a question to revise what we have learned. The rest state and motion of a body are. The correct answer is option B. The state of rest and motion of a body is never absolute, it depends upon the frame of reference of the observer. Distance and displacement. Distance and displacement are fundamental concepts in physics that describe how objects move and their final positions. They are related but distinct concepts. Distance. Distance is a scalar quantity that measures the actual path traveled by an object. It is always positive or zero and represents the total length of the journey. Distance never decreases with time, and its SI unit is meters. Displacement. Displacement is a vector quantity that describes the change in an object's position from its initial point to its final point. It considers both the distance and direction traveled. Displacement can be positive, negative, or zero, depending on the final position concerning the initial position. Displacement can decrease with time, and its SI unit is meters. Here are some important points to consider. When an object moves in a straight line without changing direction, the displacement, change in position, is equal to the distance it travels because it's going in a straight line. However, when there's any change in direction, the displacement is always shorter than the total distance traveled, as it takes the shortest path. So, the ratio of displacement to distance is always less than or equal to 1. If an object starts and ends at the same point, the displacement is zero because there's no net change in position. Let us understand distance and displacement with the help of some examples. An object moves along the grid through points A, B, C, D, E, and F as shown. The side of square tiles measures 0.5 km. Calculate the distance and find the magnitude of the displacement of the object. Here's the solution. The distance covered by the moving object is the length of the total path covered is equal to AB plus BC plus CD plus DE plus EF. Since each square tile measures 0.5 km, then AB will be 3, BC will be 1, CD will be 1.5, DE and EF will be 0.5 each. The distance covered by the moving object is 6.5 kilometers. To find the displacement, we will find the distance AF, which is the shortest distance between the initial and final position. Applying the Pythagorean formula, we get AF is equal to 2.5 km. So, total distance covered is 6.5 kilometers and displacement is 2.5 km. Let's understand the concept of point mass object. A point mass object in physics is an object for which its motion can be simplified as if it were concentrated at a single point, even though it may have physical dimensions. This approximation is used when the distance it travels is significantly larger than its actual size. For example, a satellite orbiting the Earth is often treated as a point mass object. While satellites do have physical dimensions, they are so small compared to the vast distances they travel in space that their motion can be effectively simplified as if they were point masses. Treating them as point masses makes calculations for trajectory, orbital speed, and gravitational interactions with other celestial bodies much simpler in the field of orbital mechanics. This approximation streamlines the analysis and prediction of satellite motion in space. Let us discuss the topic speed and velocity now. These are concepts that help us understand how objects move. We'll start with speed. Speed. So, what is speed? Speed is essentially how fast something is moving. It's defined as the time rate of change of an object's position in any direction. In simpler terms, it tells us how quickly something is getting from one place to another. The standard unit we use to measure speed is meters per second, m/s, and it's a scalar quantity, which means it has only a magnitude, not a direction. Uniform speed. Now, let's talk about uniform speed. When an object covers equal distances in equal intervals of time, we say it's moving with uniform speed, and this type of motion is called uniform motion. Imagine a car, for example, traveling 300 kilometers in 4 hours. To find its speed, we use a simple formula: speed is equal to distance by time. In this case, its speed is equal to 300 kilometers by 4 hours is equal to 75 kilometers per hour. So, the car is moving at a constant rate of 75 kilometers for every hour of travel time. Average speed. Now, let's delve into the concept of average speed. It quantifies the relationship between the total distance traveled and the time taken. Formula to calculate average speed is total distance traveled upon total time taken. Another useful formula to calculate average speed, especially when an object covers equal distances with different velocities, v1 and v2, is average speed is equal to v1 v2 by v1 plus v2. Let's put this formula to work with a real example. Imagine a car that travels 60 kilometers at 40 kilometers per hour and then covers another 60 kilometers at 60 kilometers per hour. Since the distance is the same, we can apply a formula. Average speed is equal to 2 into 40 kilometers per hour into 60 kilometers per hour by 40 kilometers per hour plus 60 kilometers per hour is equal to 48 kilometers per hour. Consequently, the average speed of the car during this journey is 48 kilometers per hour. Non-uniform or variable speed. Lastly, let's touch on non-uniform or variable speed. When an object covers unequal distances in equal intervals of time, we call it non-uniform or variable speed, and this type of motion is called non-uniform motion. Think of it like this: if you're driving, and your speed keeps changing every few seconds, that's non-uniform motion. Let's analyze the situation. A train embarks on a journey from New Delhi to Kolkata, where it covers 400 kilometers in 7 hours and then continues with another 550 kilometers in 8 hours. The question at hand is whether this constitutes an example of non-uniform motion. Non-uniform motion. To determine this, we calculate the speed of the train in each segment. In the first part of the journey, the train's speed is 400 kilometers divided by 7 hours, which yields 57.14 kilometers per hour. In the second part of the journey, the speed is calculated as 550 kilometers divided by 8 hours, resulting in a speed of 68.75 kilometers per hour. Since the train exhibits different speeds in both segments, this scenario exemplifies non-uniform motion. Now, we all know what speed is, but velocity takes it a step further. Let's get started with the topic of velocity now. Velocity is essentially the rate at which an object changes its position in a specific direction. In simpler words, it's speed with a direction. It's a fundamental concept in physics, and its formula is displacement upon time, with its unit measured in meters per second. But what makes velocity particularly interesting is that it's not just a number, it's a vector quantity. This means it has both magnitude, like speed, and direction. It's like telling you not just how fast a car is going, but also in which direction it's moving. Velocity can be positive, zero, or even negative. That's right, negative. Imagine a car, which is an everyday example. Let's say it travels a distance of 150 kilometers in 2 hours. To calculate its velocity, we use the formula, velocity is equal to displacement time. In this case, the displacement is 150 kilometers, and the time taken is 2 hours. So, velocity is equal to 150 kilometers by 2 hours is equal to 75 kilometers per hour. The car's velocity is 75 kilometers per hour. Uniform and non-uniform velocity. Velocity comes into flavors, uniform and non-uniform. Uniform velocity. When an object undergoes equal displacements in equal intervals of time, it's moving with uniform velocity. Now, here's something cool. This is only possible when a body is traveling in a straight line without changing its direction. Imagine a car moving at a constant speed on a straight highway. Non-uniform or variable velocity. In contrast, when an object undergoes unequal displacements in equal intervals of time, it's said to have non-uniform or variable velocity. And here's the twist, this is possible only if the body changes its speed or direction concerning time. Think of a car in city traffic where the speed varies due to frequent stops and starts. Dear students, in this video, we've covered fundamental concepts of motion in a straight line, including motion and rest, distance and displacement, and speed and velocity. Stay tuned for the next video, where we'll delve into the remaining concepts.